Good morning everyone, my name is Arya, and today I am going to present my DSP practical on signal compression using MATLAB. The main aim of this experiment is to generate and observe the effect of compressing a signal in time and to understand how this time scaling operation changes the frequency and duration of the signal. In digital signal processing, a signal can be either compressed or expanded by modifying its timescale. Mathematically, if the original signal is represented as x, opening parenthesis, t, x, t, then x, opening parenthesis, a, t, x, at, as its time-scaled version. When the value of a is greater than 1, the signal becomes compressed. This means it occurs faster, and its total duration decreases. On the other hand, if the value of a is between 0 and 1, the signal becomes expanded, meaning it slows down and its duration increases. In this practical, we are mainly focusing on the compression case, where a greater than 1. A greater than 1. In the MATLAB program, we first define the sampling frequency as fs equals 1000, meaning the signal is sampled 1000 times per second. Then, we create a time vector t equals 0 to 1, fs. 1, which represents 1 second of signal duration. The base signal is generated as a sine wave using the formula x. Opening parenthesis, t, equals sin 2, pi ft, x, t, equals sin 2 pi ft, where f equals 5 Hz. To compress the signal, we introduce a compression factor equals 2, which makes the signal twice as fast. The time vector is then scaled as t underscore compressed equals t, a, and the new compressed signal is generated using x underscore compressed equals sin 2 asterisk pi f asterisk, t underscore compressed. Finally, both the original and compressed signals are plotted using MATLAB's subplot function for easy comparison. When we observe the output, we notice that the compressed signal completes more cycles within the same time duration. This shows that the signal frequency has doubled, and the waveform appears shorter and faster in time. This behavior illustrates the concept of the time-frequency trade-off, which states that when a signal is compressed in time, its bandwidth increases in the frequency domain. In simple terms, faster signals require more bandwidth, whereas slower signals occupy less bandwidth. The result of this experiment confirms that signal compression reduces the duration of the signal and proportionally increases its frequency. The total energy of the signal remains the same, but it is distributed over a wider frequency range. This principle is very important in DSP applications such as speech and audio processing, data compression, and communication systems where efficient use of bandwidth is essential. In conclusion, this MATLAB practical successfully demonstrates how compressing a signal in time directly increases its frequency, verifying the theoretical time-frequency relationship. It helps us understand one of the fundamental principles of digital signal processing, the inverse relationship between time duration and frequency bandwidth. Thank you.